Good afternoon, ladies and gentlemen. I have two honors. Welcome in room 15 where?
Learning never ends.
Learning never ends. Appreciate that. And also we have people saying learning never stops. That's the same thing pretty much, right? Okay. So anyway, what'd you get for number 9, or recipe problem of the day?
El número 9.
B.
You got A?
B.
A. Anybody else? I heard somebody else. C? Okay, this is one that we've worked on pretty recently in this class. We looked at the systems of linear inequalities, because that's exactly what we do.
Isn't this a calculator problem?
This is technically a calculator problem, but it's one where really a calculator is not needed, even though it's in the calculator section, right?
Well, why do they give us ones that we really need a calculator on the non-calculator section, but then ones that we can't even use calculator for in the calculator section?
Yeah, I'll tell you what it is. At least this is what the College Board who creates this test tells me, that what they do is they make their calculator section such that most of those problems, that they try not to give an undue advantage to those who actually have calculators. So they're assuming that a lot of people aren't going to have calculators even on the calculator section.
School provides them.
Well, the school does not, school providing them is not part of the actual SAT test. So the school doesn't have to provide them. You have to provide your own. That's the way it works. Well, that's just the way the test works. And they do, it's the same thing for AP calculus test, that on the calculus and the calculator section of the AP calculus test, only about 1/3 of them are truly ones you need a calculator for. So that's just the way they do it. They make the test. We take the test, right? So we don't have, but anyway, this one right here, what you have, it says the worker uses forklift to move boxes that weigh 40 pounds or 60 pounds each. Let X be the number of 40-pound boxes, Y be the number of 65-pound boxes. So you're going to see 40X plus 65X, plus 65Y. And so I don't see that at all here. Let's go here. I don't see that at all here. So it's not going to be B. And so what you're doing is the weight's going to be less than or equal to 2,400 pounds. So here we don't see that at all. We see less than or equal to 45. It's not that. So which one's going to be, A or D?
It's going to be D.
It's going to be A.
Yeah, it's going to be A. This one right here, D doesn't make, because they're almost self-contradictory, right?
Yeah.
Because they're like the same 2,400. Yeah, so A is going to be your answer, best answer for that, okay? Okay, next, let's go to where we're headed. We have today, as of yesterday, we kind of finished off working on section 6.1, which brings us to section 6.2. So we're going to talk about that a little bit right now. And then we'll start working some exercises today. All right? And we're not going to get super far on this, but so we're going to go over some vocabulary. Graphing polynomial functions. So section 6.1, we dealt with what kind of functions?
Linear.
No.
The ones with the change, the ones that are shifted.
Yeah, we shifted them, right? But what kind of functions did we shift? What kind were they? To what power?
Cube.
Yeah, Brian said cubed, right?
Hey, I said that one.
To the third power, which is to the third power. Yeah. Oh, yeah, to the power. Well, to the power of 3, which is cubed. Okay, good. Okay, good.
But yeah, she said it as well, Mr. G.
Good job. Good job. Good job staying connected, staying engaged in the classroom. Good work. And again, I want to recognize Kimberly. She's gone, but was she behind at all in class? No, she wasn't. So that deserves to be recognized, don't you think?
Didn't Sierra do her work when she was gone too? Sierra did her work too.
Yeah, she did, huh? That's really good. So really good. So to me, when you can take advantage of what's available to you, that's the mark of somebody who's a serious student. Do you think that student is on the road to having a successful college academic career if they do that kind of make that kind of effort?
Yes.
Yeah, so it's a good thing. So when you do these things and do the right things to stay caught up, that's sort of like a checkpoint. That am I on track? Am I on track with my habits to be successful? All right. How do you sketch the graph of polynomial in intercept form? And what happened is, I like to use a different way of saying it. Instead of intercept form, I like to call this factored form. So if I replace the word intercept with factored, to me that's a better way of saying it. Now we'll see. And then it says for this TEAK here, text essential knowledge and skills, write the domain and range of a function in interval notation.
Mr. Thoreau, I need Maddie to come sign out, please.
Okay, she'll be right with you.
Thank you.
Okay, so now in Explore 1, it says investigating the end behavior of graphs of simple polynomial functions. It says linear, quadratic, cubic functions belong to the more general class of functions called polynomial functions. And we've been talking about this a lot, haven't we?
Yeah, we have.
And they are categorized by their degree. And then it goes on to say linear functions are polynomial functions of degree 1, quadratic functions are functions of degree 2, and cubic functions, like Brian said, are polynomial functions of degree 3. It's kind of off the page here, but that's what it is, right? Degree 3. In general, polynomial function of degree n has standard form, and so we have all this language. And then it talks about the constant term, so forth. And here, I want to concentrate on this last paragraph. It says a polynomial function of degree 4 is called a quartic function, this Q-U-A-R-T-I-C function. Of degree 5 is called a quintic function, that's degree 5. And when we have higher degrees, then they're generally referred to by their degree as in 6th degree polynomial function. Do you know where there is? There's kind of a guide to remember what those things are. You know where you can find that? I'll show you. If you look at your calculator, and we go to Stat Calc. Okay, let's look at this. What do we see in Stat Calc? We see linear. What do we see right below linear? Quadratic, which is degree. Quadratic is degree 2. Cubic is degree 3, and quartic is degree 4.
I'm confused. You're confusing me with that.
So they're in order. Degree 1, which is x. Degree 2, x squared. Degree 3, which is x cubed. Degree 4, quartic regression. And I don't know if there's a quintic. Let's see if there's a quintic here. I don't think so. Yeah, so you don't have a calculator set up to do a quintic regression, which is degree 5. But anyway, this is where some of the vocabulary you can see, right? If you just forget momentarily. Okay, let's go on here to this. We have these tables. I'm going to go through this really quickly, and we'll get to these exercises pretty fast. So it says use a graphing calculator to graph the polynomial functions. Does everybody have a graphing calculator in hand?
Yes, sir.
I want you to get one if you don't have one. Everybody has one? Okay. Good. Okay, so basically, I'm going to go through these really fast. And so what is the domain of all these functions here and all polynomial functions? What's the domain of these? Yeah, so I heard somebody here. I heard it was Jaylee or Emily. I don't know which one it was. But whoever said it was right. Okay? Which one was it this time? It was Jaylee, right? Do people tell you sound alike sometimes?
No, I've actually never heard that.
Never heard that? Okay, all right.
Do we?
Well, one thing about them is for me just standing here, they are sitting in more or less the same area, right? So, just voice direction wise. Okay, and what about the range of all these? what's the range of f of x equals x?
Negative infinity to infinity.
Yeah, so was that Madeline?
Yes.
Yeah. And again, this is interval notation. It says use interval notation for domain and range, right? Okay, what about this f of x equals x squared? What is that going to be? Let's go take a quick look at it. So I'm going to come down here and put x, instead of x to the 7th, I'm going to put x squared. And we graph that. So what's going to be our range of this guy here?
Negative
Negative
infinity,
infinity, positive infinity.
Negative infinity to positive infinity?
Oh, no. You said 0 to
0, right?
Yeah, 0.
So 0. So we're going to say 0. So does that work there for that one?
Yes.
Okay, and what about x cubed? Fx equals x cubed, what is that going to be?
We plug it in.
Yeah, you could, right? And what that's going to look like is x cubed So we're going to start where? Start
Negative infinity.
low and end
High.
high. So that's going to be negative.
Infinity. Positive infinity.
And I hope you can see that x to the 4th power is going to be the same range as x to the 2. And then here for the x to the 5th, we have negative infinity hasta infinidad, right? And then down here for x to the 6th power, we should have this thing here, right? Okay, so do you notice the alternating there? And one thing I've been doing, okay, we've been having our cheerleaders, Maddie, Haley. What do we have cheerleaders do, Haley?
Odd, even.
Odd positive, even positive, even negative. So Haley's an expert at it. Maddie is too, but Maddie, alas, she's not with us anymore today. Okay, and that's going to affect our end behavior, isn't it? So as x approaches infinity, f of x approaches.
What did you ask me to read?
As x approaches infinity, f of x approaches
Negative infinity. Or positive infinity.
positive infinity, right? As f of x approaches negative infinity, f of x approaches
Negative infinity.
negative infinity. And then for this one, the x squared, as f of x approaches infinity, f of x approaches
Infinity?
infinity. As f of x approaches negative infinity, f of x approaches
0?
no,
Nothing?
no.
What is it? It's 0, 0?
No, it's, I'll show you what it is. It's this thing right here.
Oh, it's infinity?
So again, what this is your even positive. Starts,
Right?
high, ends,
Ah.
high. Okay, that's what that is.
Okay.
All right. Okay, the next one we have is as for x cubed, we have as x approaches infinity, f of x approaches
Negative, yeah.
as, and then as x approaches negative infinity, f of x approaches
Negative infinity.
negative infinity. And do you see some kind of a pattern here?
Yes.
So here we have this one, here we have this one, and here we have this one, and negative infinity here. And finally, we have, this one's going to be at double infinity, right? Okay? That's all there is, that's all there is to it, except I want you to remember this thing right here, that this one here is going to be odd, even, odd, even, odd, even. And then, just to summarize what they look like when you graph them, if we put, so we had x cubed, if we change that to x to the fifth, well, how's that going to be different?
I think it's gonna be the same.
Okay, it's going to be the same characteristics, but it's going to look a little different. Let's graph, see what it looks
It's gonna
like.
be like more spread out.
Okay, what it is, so how does this look different than x cubed?
I think x cubed was,
It starts low and ends high, just like x cubed, but what is it, what's behaving different here?
it stays on the x-axis for longer.
Yeah, it does, it really stays glued to the x-axis for a longer duration, is what it looks like. Now, it's not technically glued to the x-axis, but it looks like it, right?
Yeah.
Just the scale shows us not. If we went to a tight scale, we would see that it's not actually, right? So, let's go to, what I'm going to do is, let me do this, let me go to Zoombox. Anybody ever use Zoombox? Zoombox, what you do is you go and move your cursor and you establish the boundaries of the box. So right here, I'm going to press enter. I'm going to establish this corner of the box right here. You do this on your calculator. So press enter. And now we can go ahead and move the other boundaries of the box. So what we're going to do with this box, we're going to get a tighter view of what's really happening along the x-axis. Because I think Madeline made a good observation, didn't you, Madeline?
Yes.
Now we're going to see what it looks like if we zoom in on it. Whoops. Zoom box, and try it again, because I was supposed to press enter. So let's go ahead here. Anybody ever used Zoombox before?
I have never used it.
It's kind of neat. So enter, and come down here, and go to the right. Now I'm going to press enter. Okay? It still looks pretty stuck to the x-axis, right?
Yeah, it does.
But not as much as earlier, because earlier it looked more like this, right?
Yeah.
Well, anyway, so that just gives you a little bit, more focused look at it. Okay? And then we can change back to normal window by going to, how do you get back to a normal window?
I just usually turn off my calculator.
You could, but you go to Zoom 6, you get Zoom Standard. So that takes you back to the normal view. Okay? All right, next one. It's the same thing, but with the negative ones. So the domains are going to be exactly the same. But your range here, the range is still going to be the same for your odd functions. But for your even function, what that's going to be?
0.
Negative infinity to 0. It'll look like this, okay? And then alternating, same thing. And then we have here negative infinity, 0, and so on. So the repeating pattern. Then the right, end behavior, is end behavior the same?
Yes.
It's not the same, because as x approaches infinity, f of x approaches, let's go here, look at that. We have x, so it's negative x, right? Let's go to negative x. So as x approaches infinity, f of x approaches negative infinity. So negative infinity. As x approaches negative infinity, f of x approaches infinity. Now for the even functions, this is an even, right? As x approaches infinity, f of x approaches negative infinity, negative infinity. Okay, and just go down, I'm going to go down to number, this last one here, the sixth. So I'm going to put negative x to the sixth. What is that one going to do? Starts low, ends low. So we're going to have, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. And then similarly here we're going to have, for this negative 1, we're going to have, then this one here is going to be negative infinity, negative infinity, and finally this last one here is going to be the same as this one, negative infinity, hasta infinidad. Okay? Does that look like that's too hard? No. Okay. Okay. It says, okay, I don't want to do that, reflect. I don't want to reflect. Okay, now it talks about how many we're having in, we're talking about factored form. And we're going to go into more detail when we get the exercise set here pretty shortly. So these right here, this is what I call factored form, because you have 3 factors right here. And how do we get from this factored form, how do we get to a standard form from this? How do you go from factored form to standard form?
You have to distribute.
You have to distribute. So let's go do that. Yeah. So if we distribute here, we're going to multiply this x minus 2 by x plus 2. So we get x squared minus 2x plus 2x minus 4. So 2x and minus 2x will cancel each other. So what we have here is we have x times x squared minus 4. And if we distribute one more time, we get x cubed minus 4x. So this right here is called the, what do we call that? The standard form, right? So standard form. And this one here, up on top, is the factored form. Okay, does that look that bad? No. And then I would do this too, but we're going to just go ahead to the exercises. So let's go ahead to them. We'll get started on these, do several of these today, a few of them. So, right here. So we are right here. So I want to just finish class with doing these first 4 today. And then we're going to pick up, starting number 5 on Monday. So using graphing calculator to graph the, and also I want to do and give degree a function. A function, we want to do that too. So we have x to the 7th power. What's our domain for this guy here? Okay, what's our range of this going to be? Okay, this is going to be, is it going to be odd positive, odd negative, even positive, or even negative?
I think it's
Odd positive, odd positive. So odd positive starts where?
starts low, ends high.
Ends high. So what is this going to be for a range?
It's gonna be negative infinity, positive.
Exactly. Exactly right.
Do
Okay?
you guys think I should just start on this paper?
Yeah, I think that's a good idea. I'm in for that. Okay. Next we say end behavior. As x approaches infinity, f of x approaches,
Negative.
okay, we graph this
Oh,
as
it approaches infinity, sorry.
infinity, right? And then as x approaches negative infinity,
F of x approaches negative.
f of x approaches negative infinity. So we are starting where? Low, ending high?
Yes.
Okay, what degree of function is this? Degree what?
Degree 2.
What power is this?
It's a 2.
That's a 7.
Oh, I can't see that part. I'm sorry.
Isn't- So what I want to do for this is hand out your paper. So this is actually on your paper I'm handing out.
How far are we gonna get today?
Oh, we'll just go through problem 4. That's all.
Oh, well that's.
We'll go really fast. And I'll call on some people to do these other ones here.
I think you shouldn't call me because I don't understand this.
Well, you have Madeline to help you.
Yeah, I do have that.
You have Bryce to help you. Chelsea to help you.
Bryce, you can help me too?
Yeah, I already help you.
Not today. You don't understand it either?
No.
Oh. What? I don't understand. Mr. G, will you go ahead and get my calculator, please?
Oh, yeah.
Thank you.
It's probably not 100%
I have glasses. What about, I'll get it after we do problem 2.
Okay. Give more time to charge.
Yeah.
All right. Number 2, we're going to have
You know who has it? Sorry. Oh, yeah, I know. She won't tell me. She'll tell me if I ask. Is that the answer for number 1?
I'm going to put down degree. Okay, for this one here, we have Nolan. For 2, we have Nolan. I'm going to put down degree for this one too.
So is it degree 7?
Degree 7, yeah. So degree of function equals 7. Degree equals 7, okay? So that's number, so for this one here, if you can't see this, this is going to be f of x equals negative x to the,
So the 7, the one we're doing right now?
yeah, it's 2, number 2.
Is it to the 9th?
To the 9th, it is.
It's really hard to see on this here.
Yeah, it is kind of hard to see. So Nolan, you have what that is? All right, he has it right here. I don't know how legibly it's going to write on me.
Is that right with you? Is that correct? I didn't write anything.
Oh, you didn't write anything?
Correct. Negative x.
Yes, you're going to start high and low.
Do you want me to just,
Yeah, so domain, you figure domain range, be the same. Then your in behavior, your degree is 9.
so, it would be as x approaches infinity,
fx approaches,
9, or infinity.
okay, so for this one, as x approaches infinity, this is for number 2, fx approaches,
Can I guess?
what?
Is it negative infinity?
Negative infinity, right?
Yeah.
Okay? And as x approaches negative infinity, fx approaches,
Negative infinity. Where's that wrong?
okay, start high and low, right?
I thought it was ending low, starting low, ending
Yeah,
low.
positive.
I thought that was-
So you're starting high, ending low. Okay, what's our domain gonna be?
Negative infinity and positive infinity.
Yeah, domain's gonna be this, right? What's our range gonna be? Is our range gonna be the same?
Yes.
Yes, it is. And what degree is this?
9.
So degree 9. Okay, all right, thank you, good work. Get your sticker on that hand, see. Stay. Okay, I'll give you your paper back. Okay, you're doing number 3. I'm calling somebody in half a minute for number 3. Okay. My charge up.
Oh, Mr. G, you said I could get a sticker.
Oh, yeah, sure, sure.
Thank you.
Okay. This here.
Mr. G.
Yeah, go ahead. Finish this up here. So we're just going to go through 4 today. That'll take us right to the end of class.
Right. For 2? I have 2.
So for this one we have Chelsea.
Why that? I need a dog.
So Chelsea, what do we have for number 3?
I can't even see it. No, I think it would be positive on infinity, negative. Like for most of these were odd and this one's even.
Yeah, you have x to the 10th for 3 and x to the 8th for 4. So what's going to be our domain of this thing?
Is it positive infinity, negative infinity?
Oh, it's going to be negative infinity, positive infinity.
What, Mr. G, why is it like that if this one is different than the other? Because this one's an even one.
Well, it's really,
Okay, the domain of this and all polynomial functions is all real numbers. What's our range going to be?
Are you serious?
0 to infinity.
Thank you, Chelsea. Chelsea's voice has gone down and registered a little bit. Okay, next one, as x approaches
Infinity,
infinity, f of x approaches
infinity.
infinity, yep. As x approaches negative infinity,
Approaches negative infinity.
fx approaches
Is this infinity? Negative infinity?
infinity.
Oh.
Odd, odd. Even. This is even like this, right? And then degree what?
10. Just looking at more time for 4.
Maybe not, yeah. So here's what I want to do for 4. The last thing I want to do is I want to call somebody to be ready on Monday for 4.
And you get charged for assault.
And that person will come on for number 4 on Monday is going to be, it's going to be Madeline.
Yay!
So 4 on Monday, okay? Thank you, here. Here.
I just got all my teeth.
So Chelsea, you have your paper.
Oh.
I just stepped out there.